This is possibly the last episode from today, as I promised, after several iteration demonstrating the business logic side. Now I am focusing on data binding and live data, and how this live data is as a stream is communicating with the user interface. Here is first our demo application. First I just press sign in. As you can see, the progress indicator starts running. It was successfully logged in. Then we just execute a query and then sign out. And when we try to press query, we have an error. So that's the application we are expecting. And then of course we have some nifty feature like validation. I'm watching you, not a valid username. Yes, because this is not a valid email, so either a username here is a regular text or a valid email, gmail.com, and now it's a valid email. And then when we remove the number of characters below a value, password must be bigger than 3. Now when we press the sign in button, unauthorized failed to get DB, so everything works as expected. So now let's see how all this was done with as much as possible with data binding and live data to reduce the amount of activity programming as much it was possible. So first of all, let's check out the login activity. So the structure of the login activity is real simple. So it has an onCreate entry point with a couple of values in instance variables, for example the view model interface, the activity view model interface to communicate with the back office, and then we have an activity logging binding, and then this binding is created automatically when we have here the layout is added to our XML layout XML file, and here in this case we are adding two binding variables, one for our view model interface, another one for the activities interface, and these are the variables that we can use throughout so in our application. Let's review them quickly and immediately. This is a one directional binding, that is progress bar is listening, because progress bar is listening all of these nearly all of these are live data. So this is listening to a live data stream, progress bar visible, and this is a boolean. So when it is visible, it automatically sets the visibility to visible or gone. The way it was done, that I have a bunch of data bindings, extra data bindings, which are not available right away from the Android package. It's that simple to write data binding. I highly encourage everybody to add data binding. It's really fun to use. For example, here is my data binding. This all I wrote, so nothing nothing special here. You don't have to be an expert, but definitely it requires some experience in Android binding. So for example here, the Android visibility, when it is bound to a value which has a Boolean value, the binding function sets the visibility to either visible or gone. So this is a Boolean to the mapping of these two enumerations. So this is one kind. Another one which I'm going to explain later, that when you have an error text attributes in a layout XML, and when it is bound to a string, then we just simply set the error. The reason we needed this set error, because by default these edit text views don't have error attributes. So but we can create any number of attributes on the fly. So therefore this is my binding, data binding. So this was one of my binding adapter I used here. So normally in a big project you create once all these data bindings and then you are done. Just use them like so. And then we have here another, this edit text. As you see, there are two possibilities, two binding. This is a two-directional. So this is a mutable live data variable, and therefore this edit text, whenever the user enter any value, it automatically pumps and sends the data into this stream, and therefore the view model has the option to validate real time the values typed, as well as if and when the when the view model wants to display something in this field, just pump the value into this username stream, the live data, and then it is automatically displayed here. So in my example we can see examples for both of the situation. This error text I just explained earlier, that it is also supported by my data binding adapters, is a one directional. Therefore we have a username error, so therefore the view model, when there is an error message, it pushes the error message to this error text and it is automatically displayed. This is what you have seen on the beginning of this demonstration, these red fancy messages. Similar for the passwords, two directional binding and one directional. And then comes the button, and then here this is a lambda expression to call functions on the view model or the activities view model anyhow. So actually any value you can, not only the view model you can pass, you can also pass here the activity or whatever object. But in my opinion, when you have a clean architecture, here you can see only view models, and then every interactions are via live data streams, one directional or bidirectional, or function invocation. In rare situation, of course, I can imagine that we can have here a reference back to the Java, the login activity, the controller, we call it the controller, the activity controller. But in that case, I think it's just simply better to implement everything in the login activity. So here the concept as is in my architecture, that the XML, the data binding, is communicating only with the view model components. So therefore what's going to happen here, it calls the login async activity, a login async function, and where the credentials are coming to this login async, they are coming this way. So this is a typical scenario in reactive programming, where the data are real time, are passed over to the view model or a controller or block object or whatever they are called, and then the data are already there when the user presses the login async. So therefore there is no need to send extra values and parameters. So that's the style here, which is promoted and supported. It's that easy to use this way. And this is not only with this live data. If you watch excellent tutorials, for example, there is a guy called Zeiste, and he gives a brilliant presentation on Flutter and Dart, and RxDart, that is a reactive extension for Dart. So he explains perfectly fine how to use this pattern, and he is not the only one. There are many, it's quite common that use this architecture. And then similarly the button here is the query button again, but this time we are calling this function on the activities view model, query activities async. This example is not complete, just bear with me. So this is just for demonstration. So in a normal situation, the query parameters are coming from again somewhere else. Definitely it's not coming here. So normally a button is just triggering. Here in my explanation, in this example, the query activities actually it queries always all the activities, business one activities. So therefore it doesn't really need these two parameters. I just wanted to demonstrate that if you want to include, for example, an empty string, you can and you should use the single quote characters here to be able to use these double quotes here. And similar for the logout. So these are actually the 3 or 4 times, yes, of the data binding you can handle. Sometimes with the binding adapter. Let me just show you again. I have data binding, sorry, once more. So I also created some binding where the images are automatically loaded via a glide image library, and then set text could support directly double, float, long, integer, datetime values as well, and so on and so forth. So a myriads of possibility. String list, I also implemented a string list, load data to list view. Here you go. Even a list of strings can be bound to a list view component on the user interface. You may wonder where these values are coming from. Normally these values are coming from the fields or data values of live data streams, or member fields of model objects, model components. So coming back to our login activity, this was the activity login binding, so it is automatically loaded. So here the initialization of an activity, very similar to actually as for the fragment. We just inflate, and then we call the set content view of the activity from the binding get root, if we had a toolbar, we should call the set support action bar the binding toolbar, but in this example we don't. And then it's also important to go very important to set the set lifecycle owner. Without setting this, our data binding in an XML wouldn't work. So this is also very important. I don't really understand why it is not set automatically by default with this data binding infrastructure, but anyhow, this is explained a number of times that it is really important, and that's really true. Once I forgot to call it and my data binding didn't work. So remember to use the set lifecycle owner. And then comes the fancy part. We are loading our view models from the factory. This time, before going on, just quickly let me show you that I changed my view model slightly a lot, because now it is derived from Android view model. Terribly important to remember to make an app view model public. So it happened in my case today that this wasn't public, and for a while I didn't have any problem, but suddenly the whole application started breaking, and then the reason was that I forgot to set this class public, and that's why it didn't work. So of course this public is required only, in my opinion, when you need, but I'm not 100% sure, that when you use a separate, I think it's better always to set it public. Just forget about what I wanted to say. We are in a separate module, but no, so just make sure that it is public. Similarly, make sure that the constructor is also public to avoid crashes. And why is this important to use this application Android view model? Because it is automatically receives an application object, and this application object, the only job of them is to use the resources. Without this application, you don't have the chance to get the resources, and it's terribly important that when you are working with in a separate module with a view model, the view model is responsible to provide a text to the user interface. So therefore it's not really the job, for example, the validation messages of the user. The user interface is just doing its job. It doesn't make any decisions. Every kind of application logic, I'm not saying business logic, no way, business logic responsibility is this other module, B1S in my case, the business one service layer communication adapter module or whatever. But this is an application logic including validation and the communication between the the user interface as well as the business logic. So that was the reason we needed this application in our view model here. Okay, so I come back later. Let's come back to the activity. So that was again an important modification, but from the perspective of the login activity, it really doesn't matter what is the implementation behind. The login activity doesn't have any clue if there is any view model. The name, of course, is fancy view model. It has some information, but for the login activity, what is important, they receive an interface, and then this interface, and this is the interface which brilliant is a kind of contract explaining and showing the user, hey guys, these are the interfaces that you should implement or work with. And when you have a look at an interface like this login view model interface, you can see a number of live data. This live data, they are not mutable. That is, the user interface has the option to observe these live data streams. The B1 sessions, that is when a login result is received, when a logout result received, when an error is received during the operation. And here we have a mutable live data stream for the bidirectional communication, which I've explained in an XML, similar to the get password. Remember, this is get password. It doesn't really mean get username. It means that the username stream, live data stream. Yes, maybe the name is not really kosher, but anyhow, so this is how I name this. You can use any naming you want. And then here is another two data stream for displaying this error text. So therefore the guys in the layout, they are listening to these streams also, username error, password error. And then we have a very fancy way of controlling the progress bar visible. So in my application, all progress bar action are triggered by the view model, never the user interface. The user interface doesn't care. It doesn't know if an operation which is called on the view model is long, requires progress bar or not progress bar. And then here are the two business logic kind of application. Of course, view model is not performing directly the business logic, but when it requires that, hey guys, these are kind of events. Yes, these are the two events. That is when the user presses the login button, then this event is triggered and sent over to the login view model, and then the login activity is invoked and called. Similarly, also with the activities view model, it has a activities live data stream and throwable again for the error handling. Right. Coming back to the app view model, no, the login activity. So these were the initialization, view model factory, and login view model. And then, terribly important, I tend to forget about this: set the view model variables, set the data binding variables in an XML. So here the set login VM. So these are generated by the data binding infrastructure in Android Studio, and these are setting the values for these variables, login VM and activities VM. That's very important. And then comes our section of declaring the observer. This is a very nice way of using the method reference syntax. So I definitely prefer this way of declarative programming. Here I just simply binding, let's call it again binding or wiring. Yes, maybe that is. We have here the login result, live data stream, we are observing it, and where is our observer? This is our login result received observer, logout result, and these are practically functions. Let me see, login result, on login result received. And these are our observer functions, which are linked to to the appropriate. So this is a live data stream, and this is our handler observer function. Logout result, logout received, get activities, and error, and then also very similarly when we have also set on editor action listener. Yep, it's tricky. So when you open in Android, there is a soft keyboard and there is a button there which is an editor, and then when user clicks that button, it also triggers the login function. And then here comes our list of function, practically only receivers, or how to say, monitoring, that is when data are received, what to do. Of course, if and when we had more complex application, we could implement here a lot more complex things, but the concept here is clear, that we have the observers and they are displaying. As you see, there is no progress bar handling because it is automatically done by the view model. So in my opinion, this is clean and clear and quite straightforward and unified. No, only one way. Every component has its own place in this architecture. Let's jump over to the application view model. The application view model just implements all of these fancy objects from the perspective of the view model. Actually, every live data are mutable. In my architecture, only the view model classes has live data. I think this is, after some time of experience, that is absolutely more than enough. You don't need to define live data here and there, because here you are clear that every live data stream is in the middle of the application, therefore in between the business logic and the user interface. We are not defining live data streams on the user interface, neither on the business logic, but both are using live data for communicating asynchronously with the view model, and sometimes, of course, directly. I mean via the live data. And here are a couple of interesting things. Let's just start with the view, the constructor. What the constructor does, it first of all sets observer for all, not all and each, but everywhere where it wants to monitor do something. For example, when the username or a password is changed, therefore this is for validation. Of course, the view model is listening to that stream, and when the data is changed, it performs the validation with is password valid, is username valid, and then what it does, and then it how to say, it displays error messages, but it doesn't have to and then it also observes for the login result, logout result, activities, and errors. And why observe these? They are observing these because this is the only way that the view model can we notify that, hey, the value received back from a login, and then it automatically turns off the progress indicator. So these are the 1, 2, 3, 4 cases when the progress indicator is turned off. Of course, the user interface, the login activity object class itself has the option to define their own progress bar indicator, but this is the default and it works excellently. And then this is the possibility how you can initialize, for example, the username and the password and on the progress bar. So when it starts, then it automatically posts these values, and then the user interface is acting accordingly. So therefore these are then on login result received, on logout result received, on activities received, the list of activities, and an error received. It does nothing else, just sets the visibility of the progress bar. Possibly it is would also be possible to generate a more generic observer, but for me this was quite okay, just for observer. And then of course it would be very nice we could do some logging at the view model level, or whatever extra action would be possible. And then we have these getters for the live data, mutable live data. These are overrides. Why they are overriding? Because this app view model implements B1 login view model interface and B1 activities view model interface. Why I love these view model interfaces? So when you are working with a team, normally if you are a designer, you are not really interested in the details. However, the chief designer or the application designer, he is only interested in the functionality. So therefore, this is what normally, for example, in my case, I am doing. That is, I define the interface, and the implementation is up to one of the junior programmer, because it's not that important. So therefore this gives a clear definition what the user interface is expected to do and how it is communicate with the view model. This is what is expected from this login activity. So more or less, if you can read and you have the architecture of thinking and you have the technology, it's practically like a book, and it's that easy to implement, especially when you have the infrastructure behind the scene. Okay, and then here come some of the other observers. On username changed, this is when the name is changed. If the username is valid, then we set the username error set value valid or invalid. So every time the user types a character, we are watching and then sending out values. So when we want to erase the message, then we can also set the value to null, but it is not done here. Still it works. Really cool. Okay, and then what other thing do we have? They are not very important. Then comes get login result, another get error. And then here comes some interesting parts from the login async. Here are the definitions. Then it gets the login data source, and then a login async is invoked. So you can see here passwords and whatever IP addresses. It makes no really sense for you because they are behind a private network, so it's nearly impossible, so it's totally useless for you. So these are not publicly available infrastructure. And then we have here the logout async. Again, progress bar visibility. Here the progress bar visibility set to true. And logout async. Okay, this is what I wanted to show you. Okay, sorry. That here for the login async, we simply get the value of the username from the stream. You see, these are the streams, and then we have the strings, and then these are the strings what we are using, because when the user presses the button, the values are already there. So this view model is a state machine for the login activity. So it has every data, every important data that the login activity actually doesn't have any data. I mean, in the text field, of course, they had, but it is internal. The login activity itself doesn't have any important data. Only some technical fields, only 2 instance variables, and that's all. But those instance variables were also technical. Logout similar. Is username valid, and then is password valid, and then similar things for the activities, and then here is the query activities async, filters and select, but actually in this example they are not used. So that was our view model as well as user interface. I also explained the XML layout with the data binding and every component. So this together with these components on the business logic, which I love tremendously, for example, activities, retrofit, this completable future, and the way it's so easy to program. So this is the whole backbone of, in my opinion, a modern state-of-the-art application development. So the next job now is just to architect the user interface, and the next step would be to do the navigation components with fragments and start building the application itself, because the architecture and the whole infrastructure are set up and available.